All right, so here's a short note on the first review lesson, which is on solving equations. All right, so I want to solve these two equations right here. I'll start with the one on the left, negative 2a plus 6 equals 18. The idea is when we're solving an equation is we want to figure out the value of the missing number, the variable, in this case a. And the main idea is I want to apply the inverse operation to both sides of this equation. I want to think of this equation having a left and a right side. The two sides are equal, and I need to keep them balanced. And I can kind of do whatever I want to both sides of the equation as long as I keep the left and right sides balanced. So the idea is first, I have negative 2 times a plus 6. Well, I want to get rid of that plus 6, and I can get rid of that plus 6 really easily by subtracting 6 from both sides. And so on the left-hand side, the plus 6 and the negative 6 cancel out, so all I've left is negative 2a. On the right-hand side, 18 minus 6 is 12. And now what I have is a different equation that's equivalent to the first and is also simpler than the first. And that's the idea to all of these equations. And at this stage, it's pretty quick. But this idea can be applied to extremely complex things. This idea of applying inverse operations to both sides of the equation. So this point, to figure out a, I just have to cancel out the times negative 2. Again, negative 2a means negative 2 times a. So I'm going to divide both sides by negative 2. And so I have just a on the left-hand side, and 2 divided by negative 2 is negative 6. And therefore, I've solved for the value of a. A must be negative 6. And we always want to think about it as not moving terms from one side to the other. Please don't think about it like that. Think about it as applying inverses to both sides. It's what's actually happening, and it is far more important going forwards. So the second equation, same idea. I want to solve for b here. First, I want to cancel out the subtraction of 5, the take away 5, by adding 5 to both sides. And so I have 20 on the left-hand side and just 9b on the right-hand side. And finally, to get rid of the 9 times the b, again, it's not 9 plus b, it's 9 times b. So the inverse of multiplication is division. Divide both sides by 9. And really, I have my answer right here, 20 over 9. I have no need to change this into a decimal. If I did, I don't think it's any nicer than that. So I'm just going to write it as b equals 20 over 9. If you did decimalize it, you get 2.2 repeating forever. And again, if you like that better, fair enough. Just be exact. Put the little bar over the repeating 2. But 29ths is fine as well. If you're tempted to change this to a mixed fraction, a mixed number, in this case, that would be 2 and 2/9. That is correct, but I wouldn't really advise it. Going forwards, really, this is the one I like the best, the improper fraction. It's in lowest terms. I mean, they're all correct. All three answers you see there are correct. But going forwards in this course and future courses, just stick with a improper fraction in lowest terms, unless you're asked to do something different. All right, so just 2 more. And so same idea. I want to solve for c over here and for d over here. And again, I want to apply inverses to both sides. Let me focus on this one here. Like before, I want to start by canceling out the subtraction part. I don't have to, but I think it's easiest just to first, instead of having a subtract 6 there, let's add 6 to both sides. And so I have c over 3 equals 11. And again, over 3 means divided by 3. The inverse of division is multiplication, so I want to times both sides by 3. I'll just use a dot for multiplication. And so again, the dividing by 3 and the timesing by 3 right here cancel each other out. So all I have left is a c. On the other side, I have 11 times 3, which is 33. All right. And again, I'm applying inverses to both sides. And so lastly, let's look right here. Let's solve for d. Again, I always have lots of options. I'm going to be boring and kind of do the same sort of thing I did before. I want to subtract 5 from both sides. I got to be a little bit careful. I have just 5 on the left-hand side. If I just write d over 4 on the right-hand side, I've made a mistake because I've missed something. There's still a negative in front of the d. So I can call it negative d over 4, or if I want, it's the same as negative d over 4. It's all the same thing. Whether you think of the whole fraction as being negative or just the numerator as being negative, it's the same thing. And so at this point, what do I do next? Again, I always have choices, but I want to cancel out the division by 4. And so I want to multiply both sides by 4. And so I have 20 on the right-hand side and I have just minus d remaining on the right-hand side. Again, I still haven't done anything with that negative there, which again, minus d really means minus 1 times d. If that makes it easier, put a little 1 there. Negative d means negative 1 times d. And how do I cancel it times by negative 1? Well, I divide both sides by negative 1. Or you could also multiply both sides by negative 1. Never think there's only one way of doing this. Really, the only time there's one way of solving a problem, well, there's probably never just one way of solving a problem, but generally if there seems to be just one way, it's probably because it's either too easy of a problem or we're missing something. So I'm going to divide both sides by negative 1. In the end, that missing number is negative 20, and so d equals negative 20. And so for this first set of notes, which is getting quite short, there is no homework, but there will be some for the next lesson that I'll get through. And so for these, really, if anything here doesn't make sense, I would just review it. If this seems pretty straightforward, then I would just go straight to the next lesson. And that's all.